you woke up this morning, were you surprised to see the sun shining once again? Did you gasp in wonder at a marvelous light source that brightened the whole horizon and shed light on everything around you? My guess is probably not. The sun does its job faithfully every day, and it has such a reliable track record that we tend to forget about it. But yet, you might ask, why is that the case? Why do we see a bright golden ball of light that appears every morning, moves across the sky from east to west, and then goes down again? And why is it that on a clear night, the whole dark sky lights up with thousands of small lights in a recognizable and repeatable pattern? Well, that's the subject of our consideration this evening, the wonders in the planets and the stars, part of God's creation. But our Creator did not leave us alone staring up at the night sky to wonder about his existence. He wants us to know the truth about where we came from and what his purpose with mankind is. And so he provided his own eyewitness account recorded for us in the book of Genesis. And the Bible begins in Genesis chapter 1, as we've just considered, with the account of creation. So if you have your Bibles, if you come with me to Genesis chapter 1, and we'll start at verse 1. And it says there, "In the beginning, God created the heaven and the earth." So in the beginning was God, and God is without beginning or end. It was God that created the heavens and the earth. And so creation was the result of an intentional, powerful, and loving God that created the universe and everything in it. And in Genesis chapter 1, we have 6 days of creation recorded for us. In verses 3 to 5, we have day 1, the creation of light, the separation of light from darkness. In verses 6 to 8, we have day 2, the creation of the firmament and the dividing of the waters. In verses 9 to 13, we have day 3, the creation of dry land and seas, and land plants and trees. And in verses 14 to 19, we have day 4, the creation of the sun, moon, and stars. And this is what we'll be focusing on this evening. And so if you come with me down to verse 14, it says there, "And God said, 'Let there be lights in the firmament of the heaven to divide the day from the night, and let them be for signs and for seasons and for days and years.'" These lights that would adorn the heavens had a special purpose. They would be for signs, for seasons, for days, and for years. And really packed in this one verse is an abundance of information that, well, it really wouldn't be understood by science for thousands of years. But yet God made it known at the very beginning. So why is it that we have seasons? And how is that related to the sun, moon, and the stars? And what makes a day the period of 24 hours that we're so familiar with? And why is a year 365 days? And we'll consider some of these questions as we proceed. But it goes on in verse 15 and says, "And let them be for lights in the firmament of the heaven to give light upon the earth. And it was so. And God made 2 great lights, the greater light to rule the day and the lesser light to rule the night. He made the stars also." The sun, moon, and the stars would act like lights on the earth. And even though these heavenly bodies would far exceed the magnitude of our small planet, they were really created for our benefit on earth. And at the end of verse 16, we have perhaps the biggest understatement you can imagine, at least from a human perspective. It says, "He made the stars also." As we'll consider a bit later, the vastness of the stars of the universe is really even beyond human comprehension. But yet to God, it's simply recorded on day 4, "He made the stars also." This is the power of the Creator of the universe, the God of the Bible. And not only were these things created for our benefit, but they were also created to give us confidence in the one who created them. Come with me over to the book of Jeremiah. Jeremiah and at chapter 31. And in Jeremiah 31 and at verse 35, it says, "Thus saith the Lord, which giveth the sun for a light by day, and the ordinances of the moon and of the stars for a light by night, which divideth the sea when the waves thereof roar. The Lord of hosts is his name." So God, speaking to Jeremiah, repeats similar language to that of day 4 on creation. The God who made a covenant with Israel is the same God who created the sun, moon, and stars. And in verse 36 it says, "If those ordinances depart from before me, saith the Lord, then the seed of Israel also shall cease from being a nation before me forever. Thus saith the Lord, if heaven above can be measured, and the foundations of the earth searched out beneath, I will also cast off all the seed of Israel for all that they have done, saith the Lord." God's word is as sure as the reliable pattern of the sunrise that we witness every morning. The ordinances that God set in motion. And if we can even measure the vastness of the heavens, then there would be reason to doubt God's word concerning his people. Well, even with the advances of technology today, we still can't even comprehend the vastness of the universe, really, and let alone measure it. And every day when we witness the sun rising and setting in the sky, it's a reminder of what God has said will come to pass. We can have confidence in the God who set the planets and the stars in the heavens, and confidence that what he says will come to pass. So let's turn our attention now to some of the wonders found in the planets and the stars. As technology has increased, so too has our understanding of the planets and the stars around us. But even so, there is still much for us to learn. Space exploration really took off with the invention of space probes. Space probes are really small unmanned spacecraft that are loaded with the latest technology and travel through space to explore the unknown parts of space around us. The Soviet Union launched the first space probe, Sputnik 1, in 1957. And the Americans soon followed with Mariner 2, which was the first successful interplanetary space probe which flew past Venus in 1962. And since then, over 200 space probes have visited every planet in our solar system, as well as moons, comets, and asteroids. And they gather data using a suite of instruments and transmit that information back to Earth. While space probes actually travel to different planets and moons to explore them, space telescopes allow astronomers to peer deeper into the heavens than we ever have before. So you're probably familiar with this one, the Hubble Space Telescope. It's the largest and most recognizable space instrument, really, for the observation and photography of the universe. Being positioned outside of our planet, it really allows us to look deeper into the heavens than we ever have before, without really being obstructed by our own atmosphere. And the farther we look, the more of God's creativity and handiwork we see written across space. The Hubble Space Telescope was actually launched in 1990, and it's still in operation. It's been in operation for over 30 years. You may have seen this one fairly recently. This is the James Webb Space Telescope. It's really expected to be the premier observatory of the next decade. It's a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. It actually just launched a few months back in December 2021, although its first public images aren't expected until later this summer, in summer 2022, as after it finishes calibrating its mirrors, which apparently takes a number of months. And what mankind will discover in the future, we have no idea. But I think what these advancements go to show is that it's really only been in the last 30 to 50 years of human history that scientists have actually begun to understand the complexity of God's creation that exists outside of planet Earth. The view and understanding of science is constantly changing. We need not put our trust in current scientific thought that continues to contradict itself as new discoveries are made. What doesn't change is God's word of truth as he's revealed it in the Bible. It's been constant from the beginning. But as advancements are made, what it does allow us to do is marvel at God's creativity and awesome handiwork in everything that we see, the wonders in the planets and the stars. So just how big, you might wonder, just how big is the universe? And the simple answer is, we really don't know. A better question might be, is how big is the observable universe? Astronomers tried to quantify this, and they believe the visible universe is more than what they call 500 sextillion miles across. That's, I think, 18 zeros on the end of that. I didn't even know that existed. But there may even be beyond what we can see. It's hard to really even comprehend the incredible distances in outer space. We might wonder, well, how did it get that big to begin with? And of course, the simple answer is God created it that way. In Isaiah 48, verse 13, reading from the New King James, it says, "Indeed, my hand has laid the foundation of the earth, and my right hand has stretched out the heavens. When I call to them, they stand up together." God stretched out the heavens as part of creation, and he set them in motion. The distances are really so great in space that the measurements that we might be used to really don't work too well. They're just too small. And so in terms of space, they use different types of measurements. These are the three most common. The first is the astronomical unit, or AU, which is 93 million miles. That's the distance from the sun to the earth. And then there's the light year, which is almost 6 trillion miles in length, the distance that light would travel in a year. And then there's the parsec, which is 19 trillion miles in length. And then if you want to go further than that, astronomers use kiloparsecs, which is 1,000 parsecs, and megaparsecs, which is 1,000,000 parsecs, to measure vast distances between galaxies. So if you were to try to put some of these in perspective, here's a few different objects to get an idea. From the Earth to the Moon, it's 238,000 miles. From the Earth to the Sun, it's 93 million miles. From the Earth to Pluto, if you go out further still, it's 3.7 billion miles. To the nearest star system, which is the Alpha Centauri star system, it's 25 trillion miles from Earth, which is about 4.3 light years. The Milky Way galaxy, of which we're a part, is nearly 6 quadrillion miles across. And the visible universe, as they propose it, is over 500 sextillion miles across. The zeros just keep increasing the further you go. And it's really hard to even comprehend how big this is. But perhaps this video will help to put in perspective the vastness of the universe.
So, just how big is our universe? Roughly 550,000 billion miles across, if not more. We cannot truly detect how vast it is. To measure distances from Earth, we use astronomical units, light years, and parsecs. One astronomical unit, or AU, equals 93 million miles, which is the same distance from our Earth to the Sun. One light year is nearly 6 trillion miles. One parsec is 19 trillion miles. And within this vast universe, you are here, in the Milky Way galaxy. When galaxies bind together, they form clusters. Our local group contains at least 80 galaxies, including Andromeda. At 2.5 million light-years away, it's our closest neighboring major galaxy. This local group is among around 100,000 other galaxies in the Laniakea supercluster. some 520 million light-years wide. The Laniakea supercluster is just one of roughly 10 million superclusters within the whole observable universe. But back here on Earth, when we look up, our eyes can see the stunning Milky Way galaxy, among a few others. Galaxies come in a variety of shapes and sizes. Astronomers believe there are at least 2 trillion galaxies in just the part of the universe we can see. Ours is even said to contain around 3 billion stars and perhaps as many planets. Our solar system is in the minor Orion arm of the Milky Way and 1/2 of the distance away from the galactic center. This ideal location protects us from dangerous radiation. It also gives us a fantastic view of the universe.
Really makes you feel kind of small in comparison, doesn't it? And I think it gives another appreciation for God's words to Jeremiah when he said, "If the heavens above can be measured, I will also cast off the seed of Israel." The heavens above are really beyond measure, and such is the God and creator of the universe that we worship. But let's start our journey through space a bit closer to home in our own solar system. Our solar system is really a perfectly balanced arrangement of planets and other celestial bodies orbiting around the sun. The solar system demonstrates God's ingenuity and design in his creation. And so it includes 8 planets, asteroids, comets, centaurs, dwarf planets, trans-Neptunian objects, and even dust, all of which orbit around our star, the sun. And we can see much of the solar system from Earth on a cloudless night, especially with the aid of a telescope. Astronomers used to classify Pluto, you might remember Pluto, as one of 9 planets in the solar system, but really because of its small size, they now call it a dwarf planet. Well, there's really 2 main types of planets that are classified. The first is what you call terrestrial. And so the 4 planets closest to the sun are terrestrial, or as the word means, Earth-like, though Earth is the only planet that's fit for life. And so we have Mercury, Venus, Earth, and Mars are at increasing distances from the sun. And these are all relatively small worlds with dense, rocky compositions. And then you have the gas giants, which are the 4 outer planets. Jupiter, Saturn, Uranus, and Neptune are all called gas giants. And these planets are much larger than the terrestrials, and they're comprised primarily of hydrogen and helium gas instead of rock. But God created our solar system as a complete, intact, and perfectly balanced system during creation. And without this perfect design, we wouldn't even be able to survive. Because of really God's precise laws of nature, it makes astronomy possible to begin with. Without these consistent, predictable rules, we wouldn't even begin to be able to understand it. Let's have a look a little bit more at some of the design of the solar system.
We can easily see that without the moon and the stabilizing effects of other planets within our solar system, the world would not be the beautiful place it is for us. It's a system that works perfectly according to God's plan. And thanks to inventions like the Hubble telescope and space probes, we know more about our solar system's planets and their design than ever before. Mercury, the closest to the sun. Venus, with its backward spin. Earth, our beautiful home. Mars, the red planet. Jupiter and its violent storms. Saturn, known for its delicate rings. Uranus, rolling sideways as it orbits around the sun. Neptune, the sky-blue gas giant, and Pluto, the icy dwarf planet.
All these planets that orbit around the sun make up our solar system. So when you look at the sun, it might seem like a fairly common and ordinary star compared to others, but it actually has many unique and special features that are clearly designed to support life on Earth. The position of the sun is perfectly optimized for life. If the sun was any closer to Earth, or if Earth was any further away or closer to the sun, then we'd burn up. If it was further away, then we would freeze. If the sun was closer to the core of the Milky Way galaxy, radiation from other stars would harm life on Earth. The sun is made almost entirely of hydrogen and helium gas, and on its surface it has a temperature of about 6,000 degrees Celsius. Other stars that are hotter than the sun produce far more ultraviolet radiation that would have damaging effects on living tissue, and cooler stars would give off more infrared heat. And some stars have super flares that release deadly radiation, but our sun's flares are mild in comparison. And thankfully, our sun's temperature, its location, and its stability fall in the perfect range for life on Earth. God gave us a star that suits life on Earth just right. Let's have a look a little bit more about what that looks like.
In the book of Genesis, God said, "Let there be lights in the expanse of the heavens to separate the day from the night, and let them be signs and for seasons, and for days and for years." One of those great lights is the sun. The sun rules the day. As a main sequence star, it fuses hydrogen atoms to form helium atoms in its core. As its hydrogen burns, the sun sends out more energy every second than 1 billion cities would use in a year. Its light fuels plant growth that feeds Earth's creatures great and small. With its temperature and brightness resembling that of other similar-sized stars, it can easily be dismissed as average. But even secular scientists acknowledge the sun is truly special in its own right. While other stars have superflares that release deadly radiation, our sun's flares are mild. Our sun, along with Earth's protective atmosphere and magnetosphere, work together to protect us from dangerous radiation from space, strengthening the thought that God's great creation was truly made for us.
So one of the closest planets the closest planet to the sun is the planet Mercury. It's the closest in our solar system, and it's also the smallest planet. Travels the quickest, and it has the most elliptical orbit of any planet in the solar system. And because it's so close to the sun, it can reach temperatures of over 430 degrees Celsius. Mercury actually has very little atmospheric protection, and because of this, heat quickly escapes from the planet. And so after the sun goes down, the surface temperature can actually plummet to negative 180 degrees Celsius. I think it's a little bit of an extreme swing. And such extreme temperatures really make it completely unsuitable for life. Because Mercury is so close to the sun, it actually makes a complete orbit around the sun every 88 Earth days, giving it the shortest year of any planet in the solar system, of 88 days. Of course, the year being the time it takes for the planet to orbit completely around the sun. Next to Mercury, we have Venus. And it's our closest planetary neighbor, and it's second from the sun. But it's actually, even though it's further away than Mercury from the sun, it's the hottest in the solar system. It has a thick atmosphere that acts much like a blanket, trapping heat and warming the planet to extreme temperatures. And this greenhouse effect causes the surface temperature to reach 480 degrees Celsius, or about 900 degrees Fahrenheit. Its surface is hot enough to melt lead, and it has a landscape of valleys and high mountains that are dotted with thousands of volcanoes. With its swirling clouds of sulfuric acid and toxic sulfur dioxide that mask all of its features, it also has a crushing atmospheric pressure that's 92 times greater than Earth. Many probes have actually been to the surface of Venus, but the longest has actually only lasted about 2 hours before it burned up. Another unique feature of Venus is actually its backwards rotation. Most planets rotate counterclockwise, but Venus is an exception. On Venus, the sun would rise in the west and set in the east. That is, if you could even see it through the thick blanket of clouds. Secular scientists really don't have a good explanation for this backwards rotation, as their models assume planets should rotate in the same direction at the same rate. And so Venus contradicts this concept and rotates exactly opposite of what evolutionary models would require. Venus and Earth are often called twins because of their similar size, but their features are really drastically different. Such planetary diversity we would come to expect from our Creator. Well, then we come to Earth. Earth is our extraordinary planet, and we only have to look around us to appreciate the complexity of life that exists here. Earth is uniquely designed for life. God took special care to create Earth and designed it to sustain and to promote life. Earth is the only planet that can actually support life. Astronomers have discovered hundreds of other planets orbiting other stars, and perhaps countless more are still undiscovered. But Earth is where God chose to place the creatures that are made in His image. All other planets detected by telescopes have proved to be too extreme for life in terms of temperature, gravity, chemistry, and pressure, and they also lack liquid water. Earth is not an insignificant planet in a universe of many others. Its unique qualities are specially designed for life to flourish. And you can see here, this is a view traveling over Earth from the International Space Station. It's a time lapse as it's moving around. There are a number of features that are unique to our planet, the only planet that can support life. First of those is that its liquid water covers over 70% of Earth's surface. And of course, atmospheric pressure has to be just right for liquid water to even exist. And water, of course, is an essential for all known life. Earth orbits at just the right distance from the sun for water to actually remain liquid. If we were further away, it would freeze. If we were closer, we would burn up. Earth's atmosphere blocks ultraviolet radiation, and Earth's magnetic field deflects harmful cosmic radiation. Without these, life wouldn't even be able to exist. And actually, Earth's tilt on its axis, it's tilted as it spins. It's tilted at an angle of 23.4 degrees, and this precise angle is actually what gives us our seasons. If we had less tilt, then the polar regions, the north and the south, would receive less energy, reducing really the hospitable or habitable areas of our planet. If it had more tilt, then the seasons would be extreme and also make it less hospitable to life. Combine that with Earth's moon that actually creates the tides, preventing our oceans from stagnating. Everything is designed just so to create and sustain an environment for life. Well, when we move past Earth, we come to Mars. Mars is the most Earth-like planet in our solar system. It's a rocky world about half the size of Earth in diameter, And it's nicknamed the red planet because it actually has a lot of oxidized iron or rust. We're probably all familiar with what rust looks like. And its similarities to Earth really make it a tempting target for space colonization. There are some who would think they're going to do that. But its stark differences provide many obstacles to that goal. It has a thin atmosphere made of mainly carbon dioxide, meaning it's not a breathable environment. And so to visit, astronauts would need spacesuits with oxygen supplies and the atmospheric pressure and temperature necessary for humans. If you notice, the temperature can get down to negative 153 degrees, so you might need a little assistance to be able to survive in that. Mars also experiences 4 seasons, but since its tilt is greater than Earth's, its seasons are also more extreme. Mars and Earth have many similarities, but they also have many differences, which is another mark of the creativity of our Creator. When you move past Mars, you come to Jupiter. Jupiter is the 5th planet from the Sun, and it's the largest one in our solar system. It's actually 11 times bigger than Earth, and it has no solid surface. It's what they call a gas giant. It actually has a very speedy rotation. It takes less than 10 hours for this giant planet to rotate once. And so this gigantic world turns faster than any other planet in our solar system. And the stripes that you can see on the planet there, the swirls, are actually cold, windy clouds of ammonia and water that are floating in an atmosphere of hydrogen and helium. Jupiter is known for its great red spot. And this red spot is actually a hurricane that's twice the width of Earth. And Jupiter has no land to slow the storm down. So if you think of a hurricane on Earth, often once it reaches land, it starts to slow down. Well, since there is no land on Jupiter, it keeps going. And actually, it's been observed, this red spot has been observed by telescopes since 1664, making it at least 350 years old. That's just when they started measuring, so it could be much more than that. Jupiter has actually more known moons than any other planet, and so far that number is at 79, and that's a number that keeps increasing. Its largest moon is called Ganymede, and it's even larger than the planet Mercury. And so if it orbited the Sun instead of Jupiter, it would certainly be classified as a planet. Jupiter has another moon called Io, which actually has the highest volcanic activity of any object in our solar system. Even though it's way out past many of the others, it's almost completely covered in volcanoes. And if this moon were created billions of years ago, as some would claim, the heat should have dissipated long ago, which points to the fact of its creation being far younger than secular scientists claim. Well, when you come past Jupiter, you come to Saturn. And Saturn is the 6th planet from the Sun and the 2nd largest in our solar system. It's 9 times bigger than Earth, and like Jupiter, it's also a gas giant. Hydrogen and helium gas is what makes up most of this planet, and there's remnants of methane and ammonia that give it this sandy, yellowish hue. Saturn is known for its beautiful, delicate, icy rings, and these are actually made up of chunks of ice and rock that are coated with other materials like dust. And these can range in quite a different in size, from dust-sized grains to chunks that are as big as a house and even some as big as mountains. And you can see some of them on the bottom there, just to get an idea of what these rings are like. Interestingly enough, it's Saturn's axis tilts at just the right angle to give us a perfect view of its rings on Earth throughout most of the year. And without this, they would be almost invisible to us on Earth. Though they span over 175,000 miles across, they're only a mile thick. Another interesting thing about Saturn is it's the only planet known to have what they call Trojan moons, which means moons that share a common orbit at exactly the same speed. Basically, this means these bodies have to be precisely placed in relation to each other, or else they would collide. In other words, it requires a creator to put it in precisely the right place. When we move past Saturn, we come to Uranus. It's the seventh planet from the Sun, and it has a similar composition to Jupiter and Saturn. Astronomers believe it's composed of various ices such as water, ammonia, and methane, making it what they call an ice giant instead of a gas giant. And its small amounts of methane is what makes it appear blue. But Uranus has two sets of rings, and these are actually quite different from Saturn's. Uranus actually is unique in that it rotates on its side, unlike any other planet. And so its rotation axis is tilted 90 degrees relative to its track around the sun. So you can see the rings that are rotating vertically instead of horizontally. And this extreme tilt and rotation axis really counters secular models of solar system formation. They don't really have a good explanation for why this would be the case. It's actually a planet that the more they discover, the more surprises they find. The magnetic field of Uranus is offset from its rotation by about 60 degrees, which is another conundrum for scientists who would expect that it shouldn't even have a magnetic field at all, but it does. And this unique rotation and magnetic field really defies evolutionary models, but really fits perfectly with a divine creator. When you move past, you come on to Neptune. And Neptune is the most distant planet in our solar system. It's a dark, cold planet with supersonic winds whirling around. It's actually the windiest planet in our solar system. Winds can whip clouds of frozen methane across the planet at speeds of more than 2,000 kilometers an hour. And just for a comparison, Earth's strongest winds only reach 400 kilometers an hour. Don't think you'd want to be stuck in the winds of Neptune. It's a practical twin to Uranus and similar in size, atmosphere, and makeup. And it's the only planet in the solar system that's not visible to the naked eye. And interestingly enough, it was the only planet that was first predicted by mathematics before its discovery. It too has a system of rings and new moons, which was only discovered when the Voyager 2 spacecraft visited the planet in 1989, and it was the only spacecraft that ever flew past it. Like Uranus, it has a strong magnetic field that's far stronger than what we would expect if it were indeed billions of years old, making it seem more likely that it has a younger age, as magnetic fields decay far too quickly to last so long. When you move past Neptune, you come on to Pluto. And in Pluto, it was as they now call it, a dwarf planet. It was discovered in 1930, and Pluto was actually classified as the 9th planet in the solar system until 2006. So you might remember growing up learning about Pluto. It was only in 2006 that the International Astronomical Union voted to reclassify Pluto as a dwarf planet. The reason for its demotion was due to its size, that is one reason. It's about 18% of Earth, but also because astronomers discovered other objects that they didn't even know about before, beyond Neptune, that were similar in size and composition to Pluto. And so astronomers realized that Pluto was not an out-of-place planet, but one of what they call a new class of objects, and they call those trans-Neptunian objects, or TNOs. In 2005, a trans-Neptunian object was discovered that was larger than Pluto, the TNO Eris. And so when they discovered this, they realized, well, this was either going to be the 10th planet or Pluto had to be demoted. So they voted to demote Pluto instead. And there's actually hundreds of these icy objects in our solar system that orbit beyond Neptune. Pluto actually has mountains, canyons, and evidence of past volcanic activity, which are indicators of internal heat and a young age. The New Horizons spacecraft, which was actually only launched in 2006, took 9 years to get there, but it reached Pluto in 2015, taking the first clear up-close images of Pluto's surface, finding many things that scientists never expected to see. Well, as you go past the planets in our solar system, astronomers have started to discover planets outside of our solar system as well, and they call these exoplanets. An exoplanet is basically any planet beyond our solar system. Exo just means out of the solar system. Most orbit other stars, but some are free-floating exoplanets called rogue planets. They orbit the galactic center of their galaxy, and they're really untethered to any star. Most exoplanets that have been discovered so far are in a relatively small region of our galaxy in the Milky Way. Astronomers believe there are more planets than stars in the galaxy, and so confirmed exoplanets, at least according to NASA, are in the thousands, and that number is rising. And they're estimated to be billions in the Milky Way alone. And the closest known exoplanet to Earth is what they call Proxima Centauri b, and it's still about 4 light years away from Earth. So there's much more to be discovered about these mysterious planets, but they come in a wide variety of sizes, from gas giants that are larger than Jupiter to small rocky planets about the size of Earth or Mars. They can be hot enough to boil metal, or they could be locked in a deep freeze. They can orbit their stars so tightly that a year lasts only a few days, or they can orbit 2 suns at once. Some are like rogues, not even orbiting a star, wandering through the galaxy in permanent darkness. The creativity and variety of the heavens established by a creator is really, truly beyond measure. So let's turn our attention now, in the few minutes we have remaining, to the stars. Stars are much like the sun that exists in our solar system. They burn their own hydrogen fuel through a process called nuclear fusion that occurs at their center. And the heat of the star's center pushes out while gravity pushes in, and that's really what keeps the star stable. When it runs out of fuel, it collapses. And so in low-mass stars, as they call them, this collapse happens slowly, sometimes formulating a radiating nebula, as they call it, much like this Eagle Nebula that you can see looking through the Hubble Space Telescope. In high-mass stars, the collapse happens in a short-lived explosion, which they call a supernova, giving these elaborate, beautiful objects in the heavens. And it leaves behind a core and expanding debris that can go in all sorts of different shapes and sizes. To understand the different types of stars a little better, astronomers have come up with different classification systems. This one here is called the Hertzsprung-Russell diagram. It's a popular method of star classification. It really classifies stars based on 2 factors. The first is it's what they call luminosity, which basically how bright it is, and its temperature. So a star's color is really directly related to its temperature. Stars with lower temperatures are red, while stars with higher temperatures are blue. And most of the stars we observe are what's in this middle section here called the main sequence stars. And they span from cool red dwarfs, which are the most numerous, to hot blue stars. Our sun is a main sequence yellow dwarf. And though it's a common type of star, our sun is unusually stable, making the sun uniquely suited to support life on Earth. And then the largest of these are what they call supergiants. They can be thousands of times larger than our sun, and masses that are up to 100 times greater. And then you can have what what they call white dwarfs. They're smaller than our sun, but they share a similar mass. It's basically just pressed into a tighter space, making it far denser than our sun. And when these stars are grouped together over vast distances, they form galaxies. Galaxies are really collections of hundreds of billions of stars. And they come in a variety of shapes and sizes that really stagger the imagination. Galaxies themselves orbit each other and they form superclusters. There's really a few different main types of galaxies. The first of those is an elliptical. It's basically based on its shape. It can be spherical, elongated, and their stars orbit in these elliptical paths. So that's how they classify them, with these random orientations. They can be spiral galaxies. This is probably what most of us are familiar with. It has this bright bulge in the center, and then it has these rotating arms around it, kind of like twisted tire spokes almost. The Milky Way galaxy that we are in is a type of a spiral galaxy, a barred spiral, and itself is estimated to be 180,000 light years across, and around 300 billion stars and perhaps as many planets that make up just this one galaxy. And then others they call irregular galaxies. They don't really fit in any other category. They just call them an irregular galaxy. They don't have a recognizable or perceivable structure. While it might seem strange why these large collections may even stay together, astronomers believe that at the center of every large galaxy is another unusual feature called a supermassive black hole. And although scientists certainly have more to learn and understand about these black holes, they know more than you might think. They believe these black holes are actually the result of a massive collapsed star like a supergiant. And this massive collapse creates a gravitational well so strong that light can't even escape it, hence the name the black hole. And so these supermassive black holes are millions or even billion times more massive than our sun. And these giants appear to lie at the center of every large galaxy, and they act as kind of like a gravitational anchor for stars near the core. And at the center of the Milky Way galaxy, we have one of these, and it's the name given to it is the Sagittarius A star. Although these black holes are not nearly close enough to our solar system to harm Earth. So even though we have far more to learn about these so-called black holes, what we do know is certainly shows God's creativity, his power, and the variety that is exhibited in his universe. Let's just see a little bit more about what these look like.
But not all galaxies are spirals. Elliptical galaxies are football-shaped, while irregular galaxies show no recognizable shape or structure at all. The Magellanic Clouds are two irregular galaxies that orbit our Milky Way and can also be seen from the Earth's southern hemisphere. Another galaxy, Messier Object 104, falls somewhere between an elliptical and a spiral. It's known as the Sombrero Galaxy due to its bright nucleus and flat disk. At the center of nearly every large galaxy sits a supermassive black hole, one of the most mysterious objects in our universe. Here, gravity is so strong, nothing can escape its pull, not even light. Nearby matter can spiral in, forming a rotating disk of hot gas. Sometimes, powerful jets accelerate particles away from the disk at almost the speed of light. At the core of our galaxy sits the supermassive black hole Sagittarius A star. Watch how it pulls on nearby stars. When one star gets too close, it's torn apart. place these supermassive black holes at a safe distance from Earth. In 2019, a global team of scientists affiliated with the Event Horizon Telescope project captured the first ever photo of the shadow of a black hole at the center of a nearby galaxy.
So when you consider the amazing complexity, power, and magnitude that's on display in the heavens, it really makes you stop and wonder at the mighty God who created it all. In fact, I think the psalmist put it best thousands of years ago when he looked up and considered the majesty in the heavens. In Psalm 8, it says, "When I consider thy heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him, and the Son of Man that thou visitest him?" When we consider the magnitude and the complexity of spread across the heavens, what are we in comparison? It's like we're just a vanishing speck of insignificance. And it's a wonder that God would even bother with us. But yet he does. In Psalm 19, verse 1, it says, "The heavens declare the glory of God, and the firmament showeth his handiwork." What we see on display in the heavens is the handiwork of our Creator. It shows forth his creative power and glory. And even though there are untold trillions of stars in the universe around us, the psalmist put it this way. In Psalm 147, it says, "He telleth the number of the stars. He calleth them all by their names. Great is our Lord, and of great power. His understanding is infinite." Indeed, the God who we worship is infinite in understanding and in great power. And we can only sit in wonder and amazement at our God whose ways are past finding out. We will never really understand his greatness, but what we can do is follow what he's asked us to do. What he's left on record for us in his word of truth, the Bible. And for those who obey and follow God's commandments, there's something much greater in store. Eternal life, the gift of God to be given to those who have been faithful to him. We pray that we might all be counted among that number.